Check. 1, 2, 3, and 4. These are all vocab words. This is day 2 of scale drawings, making sure we catch you up. So if you notice, every single one of these vocab words has what word in it? Scale. So you want to make sure you know the difference between them. So number 1 and number 2, I feel like they go together. Usually, if we're going to build something, we draw it first, and then we do a little mini version, we make a model of it, and then we do our real version. Nod your heads, do you agree with me? Okay, so what I want to do with this, I feel like you guys got this down. Scale drawings, scale models. Can anybody think of a scale drawing? Something we would draw first in real life before making a model version, before making the real version. Can you think of something? Kylie, take straight in your hand. A building, totally. Guys, can you think of what the scale drawings are called for buildings? There's a name for them. Say it nice and loud. Blueprints. Good job, guys. They're totally blueprints. So scale drawings, we've got blueprints for buildings, for houses. What's something else? Let's just get one more example. What's something else we would draw it first before we make a little model version and then the real version? Corey, do you have another one? Statue, sure. You want to draw it first so you know how big you want it, and then you can make a cool little model of it. Okay, scale model, nice and loud. Raise your hands. What's something we definitely want to build before we build the real version of it? Nicole, do you have one? Sure. We could do a little mini version of a building. City planners do this all the time. Tegan, do you have another one? What about a bridge? A bridge, absolutely. We hope they build a model first. Definitely. And some of you will be doing that or have done that in Mr. K's class. Brody, do you have another one? A house, absolutely. You could do a little mini version of it first. If you guys, you know the movie Up, right? The cool, colorful house. They definitely build the model first. And then they're real models now. Have you seen the real versions? So there's one that out in like Daybreak, right? Okay, scale. Let's go to this one. Just straight up scale. This is what we talked about on day 1 of scale drawings. Scale, let's just do an example. A scale is like when you look at a map, it'll say 1 inch is, I think our example was 50 miles. So it's saying for every inch on the map, it's 50 miles in real life. So it's model version to real version. That's a scale. Okay, scale factor, we kind of talked about this, maybe just for a second, but it comes up today. Scale factor, here's the key about scale factors. They have to be same units. So these ones can take a little bit of work. So our scale, in the previous example, was 1 inch equals 50 miles. Inches and miles, are those the same units? Those would be not so fun to change to the same units. However, you'll see lots of stuff, like if you had a model version of a dinosaur, sometimes the scale, let me write it, it'll say something like 1 inch is 3 feet. So that's our scale. Model version to real version. Scale factor, I've got crazy colors up here, let me see if I can. Okay. So scale factor is take the scale and change them to the same units. So we've got 1 inch, let's keep inches. But you can't write 3 feet because inches and feet are not the same units. So can I get a hand in the air? Can you change feet to inches? Do you know how to do that? Think about it for a second. Okay, Zach T, how many inches are in 3 feet?
32.
You're close. He said 32.
36.
36. Way to fix it. 36 inches. Zach, how did you figure that out?
12 times
12 times 3. 36 inches. Nod your heads. Do you see the difference between scale and scale factor? Just remember, scale factor is the same units. Okay, let's jump to the table. Promise you, you will be pros at this table. So middle of the notes. This one they give us, do they give us scale or scale factor? Yay, we don't have to change it to the same unit. So we can just use this, change it to a fraction. So it was 1 centimeter equals 20 miles. So let's write it as a fraction. 1 centimeter over 20 miles. It's going to equal, so a proportion. Come back to the map distance. From LA to San Diego, on the map, it's 6.35 centimeters. I want a hand in there. Where are you going to put this in your proportion? Zach H, where are you going to put it? Perfect. Next to 1 centimeter, so in the numerator. How did you know that, Zach? Same unit. Here's your x. So definitely write down your setup and then bust out your calculator. Type it in. Again, definitely get the proportion set up. While you're typing, I'll show it on the board. Alright, clear this out. So cross multiply 6.35 times 20, divide by 1, we'll just come up with the same thing. 127, but is it 127 miles or inches? Miles, because this is real life, right? So 127 miles from LA to San Diego. Curious, how many of you, I beat you to it. I got the same thing, but I was way faster than you. Yay! Okay, well you keep going in the table, keep filling it in. But be careful, the scale changes depending on the cities.
So the scale, it says the scale is 1 centimeter. It says the scale is 1 centimeter to 5. So be 1 centimeter. And it equals, and it'd be over x. So you solve for that, and I got 78 miles.
Perfect. Will you constant for number 3?
Okay, so for the third one, we do 2 centimeters over 15 miles, and that equals 16.27 over x, and then you multiply 16.27 times 15 divided by 2, and I got 121.9.
Guys, raise your hand if you got the same thing. 121.9. Thanks for changing the color. Alright, Nicole, constant for the last one.
Since that one says 1/2 centimeter, I just put that as 0.5. And then I put that over 20 miles,
Nice, Gloria, keep going.
and that would equal 11.73 over x, and that equals 469.2 miles.
Guys, how many of you got this same thing as Gloria on that one? Let me see. So I heard we want to fix this one. Is your setup okay? 2 centimeters over 15 miles. 16.27. Tell us what you're thinking, Nicole.
Because when I did 16.25.
Oh, so is it just barely off? Tell us what it is, Nicole. What is it, Tegan? Help us.
I got 120.
122?
122.02.
0.025. So can I just round to 122? You okay with that? Thank you for catching that, Nicole. Way to catch yourself. Okay. Yeah. So they were close. Yeah, we're good. Read this one. Let's read the directions. Suppose we're making a drawing. I like to sketch stuff. I'm not the best, but I still like to do it. Find the length of each object on the scale drawing with the given scale. Then find the scale factor. Oh, so we've got 2 answers on every problem. Find the length and then change it to the same units. Wait, number 5. This is fantastic. Number 5, scale factor. Are these already the same units? Yay, we're halfway done. I would just write scale factor above it and then circle it. There's our scale factor, already done for us. All right, well then we've got to deal with this 16 feet then. Let's change this 16 feet to inches. I want a hand in the air. How are you going to change 16 feet to inches? You can use your calculator, but you got to know what to do. Kaylee, what would you do?
You gotta do 16 times
Perfect. How come 16 times 12? Where did 12 come from, Kaylee?
because there's 12 inches.
12 inches in a foot. Brody, do you already have it?
Yeah.
What is it? 192 inches. Okay. So here we go. Our scale factor is 1 inch over 6 inches. And we just figured out a 16-foot automobile That's really 192 inches. Scale factor is usually the model over the real thing. Model over the real thing. So where does the 192 go? It goes in the bottom because that's the real car, right? So 192 in the bottom. 100x in the top. Raise your hand, please. Oh, look at all these hands. Natalie, what'd you get? 32 inches. All right. There we go. They're fixing the air conditioning / heater. Those are the noises. Okay. Next one. Number 6, the lake. All right, the lake. Scale factor will have to do some work. Let's do scale factor last. Are you okay with that? So let's just do our setup as usual. So our setup is going to be 1 inch over 4 feet, our proportion. 1 inch over 4 feet. That's going to equal, come back to the actual lake. The lake is 85 feet. That's pretty big lake. Where does that 85 go? Hint, feet. Trevor, thanks for raising your hand. Where does it go? On the bottom, because it's feet. So keep the same unit. Alright, so let's figure out the length of it. Oh my gosh, you guys raised your hands already. Thank you for staying with us. Write down your setup, type in your calculators. Summer, what'd you get? 21.25. And Summer, is that going to be inches or feet? Inches. Perfect, Summer. Okay, are we done? Are we almost done? Yes. We just have to do scale factor real quick. So scale factor, remember scale factor, they have to have the same units. So our scale was 1 inch over 4 feet. We've got to change that to the same units. I would say you can make a choice. You can do feet over feet or inches over inches, but I would say Wanda is probably easier on this one. And then here, do you see? Jordan, what do you think? I'd say inches too. Because then, Jordan, we can keep the top. That's still going to be 1 inch. But then we have to change the bottom to inches. Okay, so you got to think how many inches are in 4 feet. Whisper to a neighbor, tell them how many. Yay, I heard it. Tell me, what is it?
48.
48. All right. So there's our second part of the answer. Scale factor, 1 inch to 48 inches. Same units. Okay, number 7. Number 7 is exactly like number 6. Solve it as usual, and then we'll come back and we'll help each other with the scale factor. Will you solve it first? Let me give you some time to try it on your own first. Is it working? Okay. Can I get a hand in there? What's just the proportional setup on this one? Gloria, how did you set this one up?
1 inch over 4 feet.
Okay, so let's jump to number. Wait, tell me again, what did you do?
Oh, wait, on number 7?
Yeah, number 7.
I did 1 over 25.
All right, 1 centimeter over 25 meters. Okay, keep going.
And then x over 200.
X over 200. Raise your hand if you did the same setup as Gloria. So Gloria, tell us what you got.
I got 8 centimeters.
8 centimeters. How many of you? I agree, I got the same thing. Okay, scale factor, dum dum dum. Centimeters, meters, I don't use them very much, so I'm not the best at this. So scale factor, we've got to change either the centimeters to meters or the meters to centimeters. Okay, so we've got 1 centimeter over 25 meters. We've got to change it to something over something. I'm kind of still thinking what Jordan was thinking. Kitty, what are you thinking? Sure, let's just change it to centimeters because this one's already centimeters. So let's keep that 1 centimeter. However, here's where the work comes in. We've got to go from meters to centimeters. Okay, what do you get to use on the CRT? Do you remember? The cheat sheet. It's called, I think cheat sheet, but it's called a reference sheet. You know what, let me show it to you real quick. I think I'll just take a picture of it. It looks like this. Cute. It's going to help you on these kind of this guy. So let's look at it. Meters to centimeters. Okay, so right here, meters. Do you agree with me? Do you see that? Where's centimeters? Right here. So start here. How far over is centimeters? 1, 2. Okay, say it again. 2, but which way? 1, 2. 2 to the right. Don't forget. 2 to the right. Come back here. 2 to the right. Help us though. 2 what to the right? Trevor, do you remember?
Yeah, you move the decimal from the end of 5 over to 2.
Perfect. He said you move the decimal, which is the end of 5, 2 to the right. So what's our final answer? Oh, good job. 2,500 there is our scale factor. Thumbs up, how many of you, I followed that. As long as I have the reference sheet, will you be okay with that? We'll practice lots more. Thanks for staying with us. Last one. All right, really fast. Make sure I do this right. 2 inches over 1 foot equals 5 feet. Where does it go, numerator or denominator? Denominator, 5 feet. I might be able to do this in my head. 5 times 2 is 10. 10 divided by 1. So I'd say 10, but it's inches, right? How many of you, I agree, I got the same thing. Fantastic. All right, scale factor. This one won't be too bad. Scale factor, because this is stuff we use more than centimeters and meters. So we've got 2 inches to 1 foot. We've got to change that to the same units. Hand in the air, tell me what you're thinking to change this to scale factor. Nicole, what did you do? Okay, so you change 1 foot to 12 inches. Okay. Nicole, I'm going to have you stretch yourself a little bit. How many of you did the same thing? You know what? They're usually simplified versions. So can you think what number goes into 2 and into 12? 2. So divide both by 2 and we get? 6. Scale factor. 1 over 6. How many of you, I got the same thing. Did you get the same thing? Yes, flip it over. I love the backside problem. First off, I love the first one. Stop. Without a setup, I think you can do this. It's saying for every 1 inch on the model, it's 8 feet in real life. So if the real train car engine, that's an engine, if the real train engine was 8 feet, how long would the model be? Done. Do we really need a setup for that? I'm saying that one's done. Hooray! You can do the setup. If you do the setup, do you think you'll get 1 inch? Yes, you will. All right, number 5, half of the McDonald's arc. Here's your teeny tiny scale. So set up a proportion. Use this as your first fraction. And then you gotta think, where does the 192 go? Are you ready to race? New mark. Get set. Go. 1 centimeter. 4 meters equals 192's got down the bottom. All right, well, at least I got my setup. Did you guys write the setup? All right, my dumb people, help me out with the answer then. 192 times 1 divided by 4. Kylie, what'd you get?
48 centimeters.
Thank you for saying centimeters. How many of you also got 48 centimeters? All right, we're on to alligator? Maybe crocodile. Probably alligator. Ready, set, go. 2 inch, 1.5 feet. It's going to equal, let's do that to feet. It's going to go here. Man, how are you guys so fast? Okay, I need help then. How long is that model of the alligator? Can you raise your hand and help me out? So 2 times 13.5 divided by 1.5. Summer, what'd you get? 18. Thanks for saying inches. 18 inches. How many of you got the same as Summer on that one? Fantastic. I told you to be good at these ones. Okay, next one. It's the same thing, just story problem form. Hooray! All right, skyscraper. Our scale is 1 inch for every 75 feet. Okay, but the model is a 19 and 2/5 inches. Yep. So where does that go? Numerator or denominator? Perfect, Kirsten. Numerator, 19 and 2/5. Does anybody know what 2/5 is as a decimal? Zach, what is it? Sure, you can use 19.4 if you want to. You can use the ABC button if you want to. I'm a decimal kind of girl, so I would probably do what Zach just did, and I would change that 2/5. 2 divided by 5 is 0.4. So I would probably think of this as 19.4. Alright, 19.4 times 75. It's got to be big because it's a skyscraper. Jordan, do you have the answer?
I think it's
1,455 feet. How many got the same thing for the skyscraper? Fantastic. One more. Are you ready? Okay, this one, Oregon, Salem, they're 64 miles apart. If the distance on the map is 3 1/4 inches, find the scale of the map. Oh, okay, this one's kind of weird. I'm glad we're doing it. Let me change it. Okay, so we've got 3 1/4 inches compared to 64 miles. It's saying on the map it's 3 1/4 inches, but in real life it's 64. So can we figure out the key? Can we figure out the legend? Usually the numerator is 1. So you've got to think, what can you times or divide by to get 3 1/4 to change to just 1? Trevor, do you know? Yes, Trevor. He said take 3 1/4 and divide it by 3 1/4. That will give you 1 inch on top. Okay, well if we divide by 3 1/4 on the numerator, what do you think we have to do to the denominator? Same thing, divide by 3 1/4. So grab your calculators. 1/4 is really just 0.25, so you can do 3.25 or just 3 1/4. 64 divided by 3 1/4. Brody, what'd you get? 19 and 9/13. How many of you? Same thing. There you go. Fantastic. For assignment, but don't let me forget, I want to help you with the first little bit. So the first page looks like this. I took a picture. Okay, here's our scale. I didn't want you to get intimidated by the scale of 1/2 inch to 1.5 feet. So right here, number 1 question, change half to a decimal. Hand in there. What's 1/2 as a decimal? Thomas thinks, what is it? Perfect. 0.5. All right, number 2, it's different, so don't use the same thing. You gotta change 1.5 to a decimal. So what's 1.5 as a decimal? Here, what is it? Yes, it is. So technically, we can use this scale of 0.5 inches is going to equal 1.5 feet. That might be helpful when you're writing your setup for the table. Okay, so let's get the setup for the first. So our scale, I'll make sure I do this right. Wasn't it 0.5 inches over 1.5 feet? All right, so there's our scale. Set up a proportion. Where does the 5 inches go? Numerator or denominator? Numerator. X, and then you can put your final answer right there. Okay, number 2, does the scale change on number 2? It's the same scale, so do the same thing. Number 2, still use 0.5 inches over 1.5 feet. And then you gotta think, all right, now that changes to 4. Final answer can go in the next box. Okay, don't forget that there's a backside.